I was asked this question in class today, and I was debating what the best way to try and solve it was. And so I guess let's just crack it. If I pick two cards from a deck, what is the chance that I will pick an ace? So I tried to say that the chances that I will pick an ace is 100% minus the chance that I don't pick an ace. Right? So it's the opposite of the chance that I won't pick an ace. So that's one way to look at it. The other way you can look at it is, well, if I pick an ace, I have two cards here. This one can be an ace, or actually let me pick a few different scenarios here. Let me pick three different scenarios here. Now that one can be an ace, and this one can be anything. I'll just put the anything as X. Or it could be the opposite. The first one can be the anything, and the second one can be an ace. Or both the cards can be an ace. In all these three situations, 1, 2, 3, I have at least an ace. I've picked an ace. The only thing is, these two situations have one ace, and this situation has two aces. So if I find the probability of this guy, right, I'll just call that P1, and I add to it the probability of this guy happening, then that'll be the chances of me picking an ace. That should be the same as this guy. So let me approach it with this first method here, and then we'll do it with this second method here, okay? So 100%. Well, before I even do that, let's say what is the probability of no aces, of me picking no aces, right? I got 52 cards in the deck, right? So that's here. And how many are not aces? Well, it's 52 minus the 4. So it's 48, right? 48 are not aces. Now, since I took one of the cards away, I've got 51 left. Now, out of those cards, how many are not aces? Well, I still have 4 aces in the deck, because the card that I pulled out, this 48, the 48 out of 52, this one was not an ace, right? It was anything but an ace. Well, how many cards do I still have in the deck that are not aces? Well, it's 51. Take away the 4 aces, or 47. So this will be the chances of me, probability of no aces. That's a real ugly fraction to multiply these two things together. So I'm just going to try to simplify it a little bit. I'm going to say, okay, well, 48 out of 52. Well, I was only talking about the aces. So there's 1 out of 13 is 4 out of 52. It's the same thing as 4 aces out of 52. So this guy up here is probably 12 out of 13. And if you want, you could divide the top by 4 and get 12, and the bottom by 4, and you'll get 13. So it's 12 out of 13. So that's with the first fraction. The second fraction, okay, there's not really much I can do. 47 is a prime number, but I know that 3 goes into 51. So how many times does 3 go into 51? It goes in 17 times. How many times does 3 go into 12? It goes in 4 times. So now I have the new fractions, 4 out of 13 times 47 out of 17. I'm going to try to do this a little bit in my head here. 47 times 4 is 40 times 4, which is 160, plus 7 times 4, which is 188 altogether. Now 17 times 13, well, that's 10 times 10 is 100, plus 70, plus 30, that's another 100, that's 200, plus 7 times 3 is 21, that's 221. So the probability of me not getting an ace is 188 out of 221. That means the probability of me getting an ace is 1 minus the probability of me not. So 1 minus 188 out of 221, which is just 33 out of 221. There's one more way I'm going to do it, but I'm going to save that for the next video.